Hello, this is Mrs. Pullen for Unit 6 in Algebra 2. I'm going to go over a couple of problems from the review sheet in this video. So we're going to start with the first skill, solving quadratic linear systems, level 3. And we have a quadratic equation, which is actually a graph of a parabola, and we have a linear equation below it. So the first thing I want to do is take that linear equation and transform it so the y is isolated. And I do so by subtracting x from both sides of the equation. Next, I know that these two y's are equivalent, so I can set the equations equal to each other. So negative 2x minus 10 is equal to 6x squared plus 5x minus 13. This is a quadratic equation, so I have to put it into standard form by adding 2x and adding 10 to both sides of the equation. I get 0 is equal to 6x squared plus 7x minus 3. Now we need to solve the quadratic equation, and you can use multiple techniques. This one is factorable, but even if it wasn't, if you were struggling with how to solve for it, you can always use the quadratic formula. But I'm going to use split the middle in this video. So I'm looking for two numbers that multiply out to a times c, which turns out to be negative 18, and add to the middle term of 7. And those factors are going to be positive 9 and negative 2. So I'm literally going to split up the 7x, so it's positive 9x minus 2x minus 3 equals 0. I group the first two and group the second two. I'm going to factor out a 3x from the first group, and I get 2x plus 3. And from the second group, I'm going to factor out a negative 1, and I get 2x plus 3 as well. I'm now going to factor out a common binomial, and in this case, it's 2x plus 3 times 3x minus 1. I'm now going to go ahead and solve for x, so I'm going to set each linear factor equal to 0. And I get 2x is equal to negative 3, x is equal to negative 3 halves. And on this side, I'm going to add 1 to both sides, and I'm going to then divide by 3. So now I have my x's, but this is a solving system, so I need to find the y value as well. So I'm going to take the linear equation where I isolated the y, that's the easiest one to use, and when I do that, I get positive 3, because that's 6 over 2 minus 10, or negative 7. So I know that one solution is negative 3 halves, comma, negative 7. And now I need to get the second solution. And so to do that again, I'm going to take the linear equation and I'm going to substitute in there. So negative 2/3 times negative 2 times 1/3 minus 10. So that's negative 2/3 minus 10. I'm just doing this in the calculator. And let me make that into a fraction. So, hold on. That's negative 32 over 3. And so my second point of intersection is negative 32 over 3, 1/3, comma, negative 32 over 3. And you would check those solutions. You can either check them graphically, or you can check them in your algebraically. But both of those are correct, and so I have those as my two solutions. I'm now going to skip to problem number 3, where we're going to solve a system of equations, a circle and a line. Again, it has to be done algebraically for this exam. Again, my first equation is the equation of a circle whose radius is -3, 3, and whose center is -3, 3, and whose radius is the square root of 53. My linear equation, I'm going to isolate the y. You can isolate the x if you choose, and that would give me -x plus 5. And now what I'm going to do is in that second binomial, I'm going to replace that y with -x plus 5 minus 3. Now you have to be really careful here because a lot of times people forget to subtract out that -3. I'm going to combine like terms, so the inside of this becomes -x plus 2. I'm going to do that now so I don't run into any problems. I'm now going to expand the x plus 3, and I'm going to expand the -x plus 2, and I'm going to multiply out the x plus 3's and the -x plus 2's. This one becomes x squared minus 2x minus 2x plus 4, and that's equal to 53. I combine like terms, and when I do that, I get 2x squared, the 3x, the minus 2x, and the minus 2x is equal to positive 2x. The 9 and the 4 is equal to 13. It's a quadratic equation. It's not in standard form. You have to subtract out the 53, and you get 2x squared plus 2x minus 40 is equal to 0. Now, you're going to have to solve for this quadratic equation, and before I do anything else, I'm going to divide both sides of the equation by 2, and I get x squared plus x minus 20 is equal to 0. The reason why you want to do that is it just makes the factoring easier. So this factors, I'm looking for two things that add to positive 1 and multiply out to -2. That's x plus 2 times x minus 4. And now I set each linear factor equal to 0, and I solve. So I get x is equal to -5, x is equal to 4. But we need to find the y values as well. And so to find the corresponding y values, I'm going to take this second equation, the -x plus 5, and I'm going to substitute in, and here I get a positive 10. So I know one solution is -5, positive 10, and now I want to get the next one. So again, into that linear equation. And when I do that, I get 1, and so the other solution is 4, 1. And again, you can either check this graphically or algebraically. I'm going to do example number 4 as the last one in this specific video. Again, I have an equation of a circle, -4, 1. -4, 0 is the center, and the radius is rad 10. And below that is the linear equation. But notice there's a -2y. So although you could do it, it just makes it a little more challenging because you end up with a fraction. Instead, I'm going to take this second equation and I'm going to isolate x. So I'm going to add 2y to both sides, so my second equation becomes 2y minus 9. Again, it just makes the algebra a little faster. Okay, so now I'm going to replace x by 2y minus 9. I'm going to combine the like terms inside the parenthesis to get 2y minus 5. And now I'm going to rewrite this. So 2y minus 5 squared plus y squared is equal to 10. I'm going to expand. So I get 4y squared minus 10y plus 25 plus y squared is equal to 10. Now I'm going to combine like terms. So I get 5y squared minus 20y plus 25 is equal to 10. I'm going to then subtract 10 from both sides because you need the equation to be in standard form. And before I try factoring, I notice that all the terms are divisible by 5 on both sides of the equation. So I'm just going to make my life a little bit easier because it's much easier to factor this equation when the leading coefficient is 1. And now I'm going to factor, looking for two numbers that add to -4 and multiply out to +3. So that's y minus 3 and y minus 1 is equal to 0. So y is equal to 3 or y is equal to 1. But now I have to find the corresponding x variables in this case. So when y is equal to 3, I'm going to rewrite that linear equation here. I get x is equal to 2y minus 9. X is equal to 2 times 3 minus 9. X is equal to -3. So one solution is -3, 3. Notice you have to put that -3 first because that's the x. And now when y is equal to 1, so it's 2 times 1 minus 9 or -7. So my second solution is -7, 1. And so you can either check your solutions algebraically or using GeoGebra. Hopefully this video helps. See you tomorrow.